So, hello everyone. Welcome. My name is Vitek Bedik. I'm the PTL of the Monasca project. I would like to give you an update on the newest changes in the project, in the Queens release and current Rocky release. So, Monasca stands for Monitoring and Logging as a Service. It is built based on a microservices message bus architecture, meaning individual services work independently of each other and communicate using a message bus. It is can be deployed highly available because of all the components are scalable. It is high performant and fault tolerant thanks to the usage of Apache Kafka as the message queue. And last but not least, it's multi-tenant. We are not only interested on infrastructure metrics, but also every project has own measurements on the VMs and the applications which they're running, and then they can define their own alarms and notifications for these measurements and alarms completely independently of each other. Short overview of our architecture. In the central place is the API, which is responsible for pushing the metrics to the system and controlling all the components. The communication between the microservices happens through the Apache Kafka message queue. We have the thresholding engine responsible for evaluating alarms, notification engine for alerting, transform engine for creating aggregations, Persista for storing measurements to the time series database. We also have a configuration database. Thank you. For storing configuration of the system. Similarly, the logging part, it is based on Elk Stack, Elasticsearch, Logstash, Kibana. Extended for multi-tenancy, we have added the API. Again, Kafka as a message queue. We're storing the logs in Elasticsearch and visualizing using Kibana with added Keystone authentication plugin for multi-tenancy. Currently, we're working on this dotted line to provide querying functionality for the log API, so you will be able to query the logs using the OpenStack API. Shortly, the statistics from the Queen cycle. So we had contributions from 19 organizations and 72 individual developers, coming up to the number of 40,000 lines of new code in Queen's release. And here the main developers, the main contributors, main companies. So we have companies being for a while now, like HPE and Fujitsu. SUSE has been very actively contributing to the project, and we have some newcomers like OP5, StackHPC actually coming back to the project again after a break. So as you can see, so we are a small but active community with a diverse affiliation. Now to the features implemented in the Queen's release. In Monasca, we use InfluxDB as a time series database. It's probably the best open source time series database as of now. It has great performance, capable of storing large amounts of data. Has a very flexible, nice query language. The only drawback is that clustering is only available in the enterprise version, which is very expensive. So we decided to add support for Apache Cassandra as a time series database. It is a proven general purpose database used in hundreds, if not thousands, deployments in different scenarios, scales very well. The downside compared to Influx is you cannot use it so straightforward as Influx for time series. You have to do some implementation. So you have to do some programming work to be able to use it as time series. So we have decided to do this work. As the target for testing, we set an environment for collecting 50 billion measurements in a retention period of 45 days, which corresponds more or less like of monitoring 200 compute nodes and 8,000 VMs in the collecting interval of 1 minute. And the requirements were fulfilled. I'm sure we could address even bigger deployments because, as I said, Cassandra scales really well. Though there are some limitations as well. One of them is the maximum row width in Cassandra, which corresponds to the time series, which we can save. So depending on the collecting interval and the retention period we have, it can become a limitation for us. Another issue is the data storage requirement. Because of the data model we use in Cassandra, storage requirements are higher, much higher than in InfluxDB. So you need more disks. One last note, perhaps, on Cassandra. Yeah, we had to do some programming for this, but it was well because of the modular architecture of Monasca. It was the code was well isolated from the rest of the system. It was nice, clean implementation, just touching the API interpersistor. It proves the quality of this architecture. For visualizations, we use Grafana, and we have done some time ago already. Implemented the Monasca data source for Grafana, which is implemented as a plugin. Apart from this, we have implemented keystone authentication, which allows authentication of the requests using OpenStack credentials. So yeah, and apart from this, it provides the mechanism to map Grafana organizations to OpenStack projects. So every project can define in Grafana own set of dashboards for this given project, depending on the metrics which are collected and the use case a given project addresses. Yeah. The only problem with this is that we have never managed to upstream this implementation, and the code is in the fork of Grafana version 4.1, which became quite old already now. And to overcome this, we have added another authentication mode to Monasca data source. We call it Horizon mode. It uses the Horizon plugin to authenticate and proxy the request from Monasca data source through Horizon to Monasca API. So it passes the Horizon session cookie to Monasca API. Yeah, it works quite nice. It does not provide all the functionalities of the standalone mode, but still, you have now two options. So you can choose to work with the older Grafana and use these Grafana organizations, or you can work with with vanilla Grafana with the newest version and Horizon authentication mode. Most development happened probably in the Monasca Agent. We have added a few new plugins, like, for example, Ceph, which actually has been added already in Pike, but we haven't really advertised this, so I have added it here. So Ceph monitoring, monitoring of Linux containers, also contribution from Orange Labs, added plugin for measuring network congestion. A lot of work has happened around monitoring containers and Kubernetes, also application monitoring. So we have new metrics for cAdvisor plugin, Kubernetes, Prometheus plugin, which scrapes the metrics from Prometheus endpoints of application having Prometheus instrumentation. Last but not least, we have added new aggregated metrics to the libvirt plugin. We have also worked on OpenStack-wide Goals. We have made good progress on adding support for Python 3. We are still not finished. We have 2 components left, but we are in a good way. We have added WSGI deployment support for the APIs, splitted the Tempest plugins to own repository, and added registration and documentation of policy in code. Actually, also still not quite finished, but almost done. Right, for the features in the current release, what we work on, we finally want to add support for Alembic database migrations. So every time when the schema of the database, of the configuration database will change, it will be easy for the operators to upgrade to the new version. Obviously, quite important feature for operators. The implementation is there in review, should be merged soon. We want to upgrade middleware, most importantly, Apache Kafka. On one side, we want to upgrade the Kafka itself to the current stable version, but also we want to change the client. We want to make use of newer. So we are using Python Kafka in the synchronous mode at the moment. We want to profit from newer asynchronous interfaces in the newer versions of clients, which will allow a great boost in the performance. According to the benchmarks, we can achieve around 10 times better performance in terms of throughput. Apache Kafka being the central part in our architecture, of course, it will require extensive testing, both in terms of performance as well as fault tolerance and stability. Ceilometer Publisher. So Ceilometer, after collecting the measurements and normalizing them, can publish them using several transports. The default one is Gnocchi, but Ceilometer provides also several different types of transports, and we have proposed change to. We have proposed a Monasca Publisher for Ceilometer, which would be responsible for pushing Ceilometer measurements to Monasca API and storing them in the Monasca time series database. Of course, we could also implement own checks in Monasca Agent, but that would be kind of reinventing the wheel. So yeah, we would like to avoid this. And also, Ceilometer is much better integrated with OpenStack components. So we thought it will be a better option. Yeah, the change is there. I hope it can be merged in the Rocky release. Another feature is around notification engine. So in the monitoring system, you want to have information from as many sources as possible. You want to have as many metrics, and also you want to be notified about every anomaly, every failure. On the contrary, if you have too many notifications, it becomes inefficient because you cannot react to all of them. So you want to have a mechanism to group them together, to be notified only once if some group of alarms are related to each other. Another scenario is when you have, for example, a maintenance in your deployment, and your upgrading system, and you know some alarms will fire, so you want to silence them for this period. And the last one is if you have alarms which are caused one. So if you have one root cause alarm and subsequent alarms of them, so you just want to have this one root cause alarm and inhibit the rest of them. So alerting manager would address these issues. It is almost ready. Hope it can be matched in Rocky. Also related to notification engine, we want to add templating for webhook notifications to allow flexible integration with external services. I'm running slowly out of time, so I'll speed up a little. When talking on this, I would like to mention our participation in the self-healing SIG, which has been started not so long ago. The goal of the SIG is to provide auto-healing and optimization of OpenStack, and the goal is to coordinate the work between different projects. So we want to cooperate with projects like Vitrash, Watcher, Congress, Heat, Ceilometer, to be able to create such infrastructure. There is a session tomorrow, a forum session, I think it is, of a self-healing SIG. So if you're interested or want to work on this, please join. CloudKitty integration, CloudKitty being a rating as a service project used to create billings, like translate measurements to the prices. They have added a collector for Monasca, so you can use measurements from Monasca to create billing. Added in Queens already. One last important development I wanted to mention is Monasca integration in the Kola Ansible project. So it has been, Monasca has been criticized many times that there is no easy way to deploy it, which is getting better now. So we have Monasca in the SUSE OpenStack cloud. It comes with it. We have the Monasca Docker project, which deploys Monasca with Docker Compose, with containers. We have Monasca Helm. OP5 is deploying based on this in the Kubernetes cluster. There is also OpenStack Ansible project. We're not actually maintaining this, and it can be a little bothersome to install with this, but yeah, anyway, there are some options. And of course, you all know Kola is gaining more and more popularity. So it will be really great to have Monasca in the Kola distribution as well. Yeah, so Stack HPC is working on this. I hope they can finish in Rocky. We want your feedback. Please contact us on any channel you like. We are using the mailing list OpenStack Dev. Please don't forget to use the Monasca tag in the subject. We are at IRC in the OpenStack Monasca channel. We have weekly meetings on Wednesdays, 3 p.m. UTC time. Yeah. From the time zone, we are mostly based in Europe, but there are also several guys in the US. So depending, you might want to choose IRC or mailing list or join the meeting. How to contribute? We need reviewers. So we have a board in Storyboard tracking implementation of the prioritized features and reviews. So you could have a look there. You could help on filing bugs and fixing the bugs. We have the work list in Storyboard. OpenStack-wide Goals, installers, documentation, and actually any forum which you find suitable. If you want to contribute to the project, please join the Monasca project onboarding session, which will be in half an hour. Johannes and I will be leading the session. Yeah, please ask questions. Perhaps I can answer. Any questions? No? Then thank you, everyone. I think we're